Hi everyone. With the Puma becoming the default in version 13, I wanted to go over how timeouts work in Puma and how its threading model works and just general differences from Unicorn. Okay, so with Unicorn, each worker is its own process. So they're isolated, and then there's a single thread for each one. Actually, they have multiple threads, but only one real thread going on there. But with Puma, it's cluster mode. So basically, you have n processes. So if we look in GitLab RB, we have number of worker processes. So in this case, we set 2, and then each worker process will have a number of worker threads. So those are the ones that will actually go and really do the processing of the request. So here we have a min and max of 4 threads per worker. I guess some testing has found that's the most efficient, but you could set the min and max to be different. So if you wanted to throw a scale up and down, that's possible. Anyway, so we should have 4 threads in each process and 2 processes. So if we do a PS for Puma, actually, let me do an AUX first. So we have this one here, Puma 433 GitLab 2. Here we're listening on the socket and TCP 8080. This is the master Puma process. And then the cluster worker 0 and cluster worker 1 are the ones that will actually be taking in the requests. So this one is just kind of there to monitor and create new worker processes as needed. It doesn't actually take traffic. These two are the ones that will actually do the work. And then if we look at the threads, let's just do one here. Run there. There we go. Okay. So you can see we actually have a fair number of threads here beyond just the 4 that we're expecting. So get rid of grep count. We actually have 19 threads, which is way more than 4. But if we trace it, then we can see that we're only actually seeing 4 of these threads really take traffic. So here we'll just grep for Puma, print the PID, and then trace it and spit it out to threads. And here we'll just kick off a bunch of API requests in parallel, so we saturate all the workers and make sure that we are getting all the threads working. Okay. So that's going, we'll give it like 10 seconds to go so we have enough data. Okay, that's probably long enough. So now if we go into the file, let's just look for HTTP. Yeah, okay. So that's receiving from, okay, yeah. So this in strace actually, so the process ID you see here is not the process ID you necessarily see in PSAUX. It's the thread ID, the lightweight process ID. So in this case, you're going to see each Puma thread will have a unique process thread or PID there, like we saw here. So it's actually this number here that we're seeing in strace, 1649596, etc. So let's just see which of these processes are actually hit in the strace. So we're just going to look for a process that has received from and then HTTP after that. That should be good enough. So if we take that and then let's just make sure that looks right. I think it's 4, right? Let's find out. That looks right. Okay. If we search for that, we search. It's not going to leave at the end. Oh, that's right. We need the file, don't we? There we go. Okay, so we're getting results. Now we can pipe that to awk again. And sort. Okay, so for cluster worker 1, even though we have 19 threads, only these 4, 16,500, and the 3 after that are actually doing web requests. So that's one thing to be aware of. You'll see a lot more threads in PS that are actually taking traffic. The other thing, the big change from Unicorn is how timeouts are handled. So in Unicorn, the worker timeout sets a maximum duration of a request, right? So if the worker has spent more than n seconds on that request, then it gets killed and the request drops. With Puma, worker timeout works a little bit differently. So worker timeout is if the worker process does not respond within whatever timeout you've set. So in this case, I've set it to be arbitrarily large, 300 seconds. But what will happen is so long as the process itself is healthy, it will pass these health checks. So that means that if you have a single thread that is taking a long time, that will not trigger the process to be killed by a timeout. So if the process got stuck, the process itself became unhealthy, then you'd see this come into play. But in terms of like a long-running request from a user, that doesn't happen. So how do we handle requests that take a long time? Well, as it turns out, we just hard code a time limit. So what I've done, you saw in the GitLab RB, I set the worker timeout to 300 seconds just for that example. And I've set my Gitly timeouts to be 250 seconds. So really long. Now what I want to do is just take a query on the GitLab repo that will take a long time. So let's take version 6. Come on. Take version 6.0. I don't even know how many years ago that is. But this should take a long time to do, for it to process. So if we run that, and then we wait 60 seconds, we'll see that the request times out. What else can we talk about while we're waiting on that? I guess we can look at the previous timeouts that they had. To Rails. You on here? I don't. Okay. Actually, I don't have exceptions that just on here. Interesting. Okay. Anyway. Go away. I might have. That's right. We're going to get a new one soon. There we go. Okay. All right. So now we got our 502 error. But you'll note that was after only a minute, even though I set all my timeouts to be 5 or 10 minutes. Well, 5 minutes. So if we look here, hopefully we'll see something nice. Actually, we're seeing a 302. That's interesting. Yeah, it's not showing there. Weird. Let's go back to Puma. Nothing there. Did the worker get killed? So we had one memory kill there. Yeah, okay. So actually, in this case, we had a memory kill. Okay, well, that's good. So that's what memory kills look like in Puma. They actually go to Puma standard out, not standard error. I should talk about how the memory totals there are. So so here per worker max memory MB is per worker process, not thread. So we're allowing 850 megabytes per worker process, but that's not the number you see here. You see that we got this, we're consuming 2,000, and at that point we get killed. So what actually happens is this limit here is the sum of all the workers plus some other constant for the master process. So the number you see here when it gets killed is not going to be the number that you see in your GitLab RB, but that's normal and okay. All right, so let's raise our memory limit here. So we get a nice timeout instead. So let's just set it to 2000. Funny. Let that reconfigure. All right, and so here, when Puma is still coming up, actually we don't even see it, yeah. So you'll see the master process come up here first, but you don't see the cluster workers yet. So this is an easy way to tell, is Puma actually available to take traffic? Because if you only see this one, then you know that, and you don't see any cluster workers, then you know there's nothing available to actually take the requests coming in. So unlike Unicorn, where it's like, well, I see a process there, but I don't really know what it's doing. With Puma, if you don't see a cluster worker, you know that it's not ready to take traffic. So that's slightly convenient. Okay, cluster workers up. And we're thinking, oh, actually, now we're going to get that long request. So let's just give that a minute to run, literally a minute. Okay. All right, so we'll give that a minute. Anything else we need to look at in the RB? Never threads, timeout. Yeah. Oh, so for customers who have a slow instance, their storage is not great, and or maybe they have a big repo, and they just need to be able to get longer running requests. Right now, the only option they have to take to have a request that takes longer than 60 seconds on Puma is to not use Puma. They have to use Unicorn. And then in that case, they can use their worker timeout like normal, and that'll be fine for now until we get rid of Puma. So hopefully we'll get this configurable for those customers who need it. Oh, this timeout loaded. Darn, that's terrible. How long does it actually take? Uh, 56 seconds. Maybe I need to take a older one. Let's try. All right, version 4.0. Hopefully that's long enough. Yeah, so apologies for the dead space here. I was hoping that would have failed, but we were too fast this time. We don't care about that. Oh, and just to be clear, just like with Unicorn, there's no reason to manually set your number of worker threads or processes here. I just did that so it'd be easy to see. Um, it'll do the automatic calculation for how many processes to use, and threads will always be 4. There we go. Okay. So now, do we have exceptions? No, we still don't have exceptions. It's disappointing. Here we go. All right. So here we can see with this rack timeout request timeout exception, request took longer than 60,000 milliseconds. So that is the actual error that we've added to Puma, because by default, Puma itself doesn't have a way to kill a long running request. So we've kind of jury-rigged this in to make sure that we don't have infinite requests running. Yeah, so that's it. So the timeout is a big thing to be aware of. Other than that, yeah, it seems like a nice improvement on Unicorn. All right. So thanks for watching, everyone.